Okay, I think now, I hope it's better. Ali, you still want to say something, or this is from before your hand is raised? Okay, then
I forgot to lower my hand.
okay, then I'll go through quickly the lecture, and then if you have any question, anyone can please ask. So today, basically, I hope that you have seen the video which I uploaded before. We are going to discuss about the polarity of the feedback. Means once you see any circuit, you want to decide, is it a positive or a negative feedback? So that you know, most likely you are aiming for a negative feedback. Just to make sure that the circuit is doing what you want, you can do this simple test that we are going to do now. So basically, what you will do, the first step, is that you want to assume that the input is increasing a little bit, and you want to see what changes is going to happen in the circuit, and will these changes be supported by the feedback, or they will be opposed by the feedback. If the feedback supports the effect of increasing the input, this means the feedback is positive. If it is going to oppose those effects, this means a negative feedback. Now, before we move and check what are the changes, I want you to know three important things. Okay, now if we have a common source, we have a source follower, and we have a common gate. If you are applying a change or your input, source follower common source, as you know, the input is applied on the gate of the transistor. So if you assume that your input is being increased on the gate of the transistor, and you are checking at the drain of the transistor, the common source has a negative gain. It's minus GM RD. So if you increase your input, at the drain, you expect the output to be dropped. Okay, so this, we must know this thing. If the input is coming at the gate, you are checking at the drain, input increase, gate increase, the drain is going to be dropped. You must know this. Similarly here, in this case, if you are applying the input at the gate and you are checking at the source side, it's going to be a source follower. And in this case, if you are increasing the gate, the source will follow it, and it's going to increase as well. Yes, Ali?
Ma'am, you said that this is a test for negative feedback. So are you saying that in common source case,
Yes.
as the gain is inverted or it's negative, so if the output is decreasing, then it is a negative feedback?
And here still there is no feedback at this moment. We are just checking the case of the transistor so we can go through the entire circuit that's here. Just here a simplified way. So when I'm going to talk about any transistor of here, you know from where I am bringing it goes up or it goes down. So I did not discuss any feedback yet.
Okay. Thank you.
Okay. Yeah. Now the third and the last case, if it's a common gate, the input is applied at the source side, and you are taking the output from the drain. If the input is increased, it's also going to increase the drain side. Source increase, drain size will also increase. This is because the gain of a common gate is also positive. So you must know these things. If you know these three things, the rest is going to be much easier. Okay, so now we keep this in our mind and we come back here to the main set. Yes, Hamza, before I start, yes.
Yes, ma'am. I'm so sorry, but can you repeat all these three things? Common gate increases as the input increases, the source follower increases as well when the input increases, and the common source decreases when the input increases.
Yes, because the gain of a common source is a negative. Yes, so you must know those three cases. Then the things, we will depend heavily on them. Okay,
Thank
so
you.
those should be stored in your mind. Okay, now we come back here. Now, if I'm starting from the input and I want to go through reaching till the output and go back through the feedback and see what changes this is going to bring to me. So if I am increasing the gate and I am seeing at this point here, it's going to be a source a common source case because the input is applied at the gate and I am checking at the drain point. So it's going to be a common source. So according to what we just said down here, if I increase the input, the output is going to be going down because it's a common source. Okay, so the output is going to go down. Now this point is same as this point here. I mean, there is a wire that's connecting them together. This means that this point is also going down because it's the same node. Okay, now I am applying an input at the gate of transistor and I want to go to the output. So I am taking to the drain of this transistor M4. So gate of M4 input is going down. What's happened at the drain of M4? It's going to go up. Why? Because this is again a common source case. So the output is going to be going up because the input is going down. The gain again is negative. Now this is the same as the output node. So this means the V out is also going to be increased. Now we want to see, we have seen the forward path, how it has been changed. The input increasing, the output is also increasing. Now, will this be supported by the feedback or no? Now, what happens to this gate of M2? Because this is the feedback direction. Since this node VG of the M2 is dependent on the V out through this voltage divider. So if V out increases, this means this node is also going to be increased. We said that this node is R2 over R1 plus R2 times V out. So if the ratio remains the same, but if V out increases, this node is also going to be increased. Now going from here to here, what happens? This is a gate of a transistor M2 going up, and I want to check at the drain of this transistor. So since it's again a common source, this is going to be going down. Why? Because again, common source is inverting. You can see now what's happening here. The input increasing the input has caused V out node to go up. Somebody mic is on. Please mute it. Okay. So if the V increasing Vn has caused V out to goes up, while the feedback path has caused the V out to goes down. You can see those two opposing arrows for the same node. This tells me that it is a negative feedback indeed. Okay. Now, any question on this? It's clear. Anybody wants to ask at any node what happened? Somebody is sending message. Can you repeat the last line? Okay. Basically, again, we discussed that Vn has caused all through this entire path reaching to V out, caused in the pink line that V out is going up. Okay, now we went through, started from V out and go back through this path that is here. We have seen that this node is also going up because again, it depends on the voltage divider with the V out. Now, VG goes up, it's going to cause the drain side to go down, and the drain side is also connected to V out. Now, again, we're seeing two arrows. One is pointing up and the other is pointing down. This means that there is an opposing effect. I mean, the Vn increasing V out, while the negative feedback is forcing V out to go down. Like this is the nature of the negative feedback. If the V out or the output is going up and start to increase, which is something undesirable, the negative feedback tries to pull it down again and return to the required range. Yes, Hamza.
Okay, ma'am, just one question. When you're talking about the negative feedback, is it the negative feedback coming into action from the right side or the left side of the circuit? So M4 is left side or the right side?
I don't know, maybe my left and right are different from yours, but this
the gate side of M4 or the source side?
The drain side of M4. I mean, this is the feedback path here from R1 and R2 going into M2 and coming back here into the output. Okay.
Thank you.
Any other question? Okay. Now let's discuss one more example. Usama, if you can please mute your mic. Yes, thank you. Okay, let's discuss this example. Now again, we're going to assume that the input is going up direction, means that we are increasing our input. Okay, now going from Vn to node A is again a common source case. Yes, so increasing Vn will cause in the pink line here, I should have used another color. Okay, in the pink it goes down because again it's a common source case. Okay, now this node goes down, it's also coming here down, and now it's in the gate of another transistor, let's call it M2. This is M1, this M2. Now the gate of M2 is going down, and again checking the drain of M2 is a common source, that's why it's going to go up. Okay, so now V out has gone up, and now this is the feedback path here. This is through like this, we are doing the feedback. Okay, now V out goes up again. This node is going to go up because of the voltage divider behavior. So now this is going up here and it's going on the source of the transistor, and we want to check the drain, what's going to happen to the drain. Therefore, this is going to be a common gate amplifier. The input is applied at the source, checking the drain. Now, if this goes up, what's going to happen to the drain side? It will also go up. Why? Because the common gate is positive gain. Now, we reach to the point that point A is the input is forcing it to go down, while the feedback path is forcing it to go up. Again, we are seeing two opposite arrows that for the same point, node, and therefore the feedback is again negative. Okay, any question on this one? Okay, now move to one more. Okay, let's see what's happening. Now we have a current input that is a current here, but we can assume that it's also, for simplicity, that it can be a voltage as well, because there can be any impedance at this node that it's, so increasing the input, let's make a color red at this moment use, is the input increased, the gate of this M1, this is M2, the gate of M1 is increased, what's going to happen to the drain side of it? It's going to go down. Again, it's a common source case. Now V output is going down by increasing the input. Now V out going down. Now this is the feedback path here. So V out is the same as this node. So the gate of M2 goes down. The drain of M2 will goes up because of it's again a common source. Now you can see two arrows pointing here in the same direction. This means it's going to be a positive feedback. Is this clear? Any question? Okay, no questions. Now the last example that I have here. Okay. Now this is again a red color. So I have the V input goes up. Again, this node is going to go up, and similarly it's connected to the gate of this M1. Now, why someone saying that why I'm not using M2 direction? I mean, why this is not the forward path of the circuit? Because there is no way that I apply an input on a drain of a transistor for M2. And this is a PMOS. This is an NMOS. Okay, so I cannot apply an input at the gate, at the drain of a transistor. It has to be applied either on the gate or on the source of the transistor. So now the Vin goes up. What's going to happen to the Vout? Vout will go down because, again, applying input at the gate, taking it from the drain. Now this is the same node as the gate of M2. So now the gate of M2 goes down. What's going to happen to the drain of M2? It will go up because, again, this is a common source. So now we can see those two arrows for the same node going on the same direction, which makes it, again, a positive feedback. Okay, now any question? Is it clear how this is, I mean, what we want to discuss for today? Because it's an important topic, we wanted to know how to decide the polarity of the feedback. Anyone have a question regarding this? It seems to be we are not having any question for this one. Okay, one more. Okay, I can repeat this example again. 1 minute. So one more time. If the V input goes up, this is in series with this node here. Therefore, it goes also up, and it's applied on the gate of transistor M1. So gate of M1 goes up. The drain of M1, which is V out, is going to go down because it's a common source case here. Now, V out goes down is also connected to the gate of M2. Therefore, it's also going down. Now, from M2 to reach to this point, it's a common source. Apply the input at the gate of M2, taking the output from the drain of M2. So if it's go down here, it will go up here. Now, since we have two arrows pointing in the same direction, this means that our amplifier in this topology is a positive feedback. If it turns out that there is one going up, the other is going down, then it's going to be a negative feedback. But this case is a positive here. Now, I want to ask something. How can I make it, I mean, suggest some change here on this circuit to make it a negative feedback? Can anybody think of something to make it a negative feedback? Hamza.
Ma'am, you can swap either of the transistors from a common source to a common gate or a source follower, just one of them. So
yes, if I replace M2 with a source follower like this, so it will look something like this. Then we have VDD here. This is M2 and this is M1, and here we have VF2. So let's do for this one here. Okay, if Vn goes up, okay, this node will also go up and it's connected to the gate of M1, so it's going to go up. Therefore, means that V out is also going to be going up. Sorry, I said mistake. V out is going to go down because it's a common source. Yeah, so now this nodal voltage at the gate of M2 is going to go down. Now, since this is going from here to here is a source follower, this node will follow the input and it will be pointing down. Now you can see here, now we have two arrows pointing in the same direction, in the opposite direction, which means that it's a negative feedback. Excellent. Any question? I hope that this topic is clear. Anybody has a question? Okay, I have uploaded for you the lectures as well as the scans of the two lectures. I am not sure if you prefer to have the videos recorded before or we just discuss the things here, because it takes like a double effort to record them and then again discuss them in the live session. And then also for you, you have to watch 2 times the videos. So that's kind of also wasting for your time. So if you have suggestion on this, I mean, we can just discuss it on the live video and then we upload the video of our discussion only. Yes, Ali.
Ma'am,
Yes.
I think so, because we're all in practice of learning alongside the teacher. In the video, the main thing was that I was unable to clearly see things because of the fact that I knew that it was a video. So if you know that there's a teacher present by the side and you can ask questions and answers, so there is a satisfaction in which we can easily learn and proceed towards the next topic. So I think so it's a good suggestion by you that we should be recording this lecture and then being going forward with uploading this ones if everyone else agrees. Because
Yeah.
just one important edge is that one of us asks a question, a lot of other questions are also answered alongside this.
Yeah, it's also helpful for me to know what I might be saying something very quickly and not thinking that it's a question for someone. So let me see some other student what they are saying. Yeah, somebody was asking question if Muniba. Muniba, so you can access, you are there. That's nice to see that you are here. If from V outside we go to the source of M2, I hope that this is on this question. If from M2 we go source of M2. Yeah, that's a nice question, Muniba. Here, yeah, I got your question. Muniba is asking now, this can be what is going to happen here. If this, I think that this is the forward path here. So I'm still, if I apply the input at the gate, sorry, at the source of M2, then I can only check the output at the drain. I don't know what's going to happen on this gate side because it's going to be a common gate. So I still have to move in this direction. Okay, that's a nice question. Okay, let me see the other chat. And excuse me if I take time to see the things because it's not easy to deal with these ones. Okay, where are the chats? Okay. Okay, so others are as well suggesting that we live session is better. Okay, so I think yeah, okay, yeah. So if anybody else want to share their suggestion later, you are more welcome, most welcome to do that. And I just want to share with you what are the next topics that we are expecting to cover. So we will skip 2 to 3 sections from this chapter 12 because I think they are more complicated than we have time to cover them in a good way. And we might not need them so much, let's say. The most important thing that we need to cover is about the stability of the amplifier. Once we decided that this amplifier is good for us, we want to make sure that it's stable. And there are some tests that you can do to make sure that your amplifier is stable, and we will discuss them in the next lecture. After that, there is an important topic it's not in this book, but I'll share with you the book that has this one, and it's about the designing of a two-stage amplifier, and that's the workhorse of all the op-amp circuits, and that's extremely and widely used amplifier. We will go on the design steps step by step, and then we will move to the op-amp circuit, which is chapter 8, and that's also very useful topic. So we can discuss them. We get more time to discuss the important topics. So some lectures will be covered by Dr. Owais, and I will come back to you after that and cover some other topics. So you are most welcome to always share your questions, your queries, and your suggestions. Okay. So this is, yeah, we still have, yeah, you today, I just want to remind you to submit your homework, number 4. We're expecting 2 more homeworks, but I'm planning on making them short, to the point, no need of extra unnecessary questions, just the questions that, I mean, maximum 4 questions that test in each homework to test your main concept that you understood what we were mainly discussing. And we will have the complex engineering problem. And that's something that I really want you to work with dedication on it. We have shifted a lot of weight from the final on it so that you can get a flavor of designing an amplifier and how it's being used on a circuit. I know some of you have complained about LT-Spice and the issues on it. We were planning on giving you another software tool, but I think it will be really now with all what has happened all over the world, it's difficult to share a new software without us being approachable to you to show you in person the things, or even that TAs cannot give you tutorials or something. So it's not good idea to share something entirely new with you and ask you to use that large software. Yes, Hamza.
Ma'am, on the topic of LT-Spice, if
yes,
it's feasible, can you ask either of the TAs to give a live tutorial on LT-Spice as well? Because they have provided us with guideline documents.
yes.
I mean, they provided us with an entire PDF at the start of the semester as well. But there are still some difficulties that most people face while designing a circuit. So if they could arrange something of this sort, and we can learn through that before the CEP comes in, that would be really helpful.
Yeah, we will. This idea is taken into consideration. So either the TAs or us will try like to show you an example during like this live session. I can show you. I open the simulation, show you how to run it, show you what kind of plots we want, what things that I want you to do. So in order to make sure that the things are clear for you. So therefore, the weightage of the midterm, the final has been a lot shifted to the assignments, to the complex engineering problems. So I want you to focus on it, especially if you want to get a good grade in this course. This is one thing. Now we remain that we still have to have 3 quizzes. I know now you will be wondering how you will have a quiz in here. So we have an option to use from LMS. So I think we will have next Wednesday a short quiz on LMS. It will be for each section during your class time, so nobody is out. Yes, I'll answer your question about the complex engineering problem. 1 minute. Yeah, just I was talking about the quiz. So we will have a kind of a short questions that you can answer on LMS in a 15 minutes slot. Now I depend that during this time you should have an internet. If you don't, then you need to contact me that I give you another question that's going to be a little bit longer, but you have to work it individually. Okay, and I assume during this 15 minutes, you're not going to ask any of your colleagues. I mean, that's why we are depending on your owner code, that you're not going to ask somebody or discuss with anyone. Now I have a question that's asking, is the complex engineering problem individual or in pairs or groups? I prefer if you can work maximum 2 students. Okay, because then if it is more than 2, then one will be working and the rest will not be doing anything. And this is very important for your learning. That's why you should be doing something, at least half of it, you should be doing yourself. So we can have the option of having it in pairs, but I don't know, will it be easier for you to discuss among yourselves since you are not meeting in person? Yes, Ali, please go ahead.
Yes, ma'am. Thank you for the
Yes.
recognition. Ma'am, I'd like to ask in regard to the quiz you're talking about on Wednesday, inshallah.
Yes.
Ma'am, we do realize that it is going to be on LMS, and almost all of us have an internet connection. But ma'am, the issue is that, for example, I have a PTCL connection, and the
Yes.
connection is really moody. So there are times it's going really well, and there are times the connection is not really good. So I can't say it right now because all of us have certain issues. Just my request would be just increase the slot to from 15 minutes, although the quiz time is 15 minutes. If you could increase it to 30 minutes, so in a worst case scenario for uploading it or scanning it and then uploading it, we have a certain time limit, because in other quizzes too we are having certain time for just uploading the quiz if it's possible.
Yeah, I mean, maybe we can increase it till 30 minutes, but I hope that this time will not be used for doing other things other than just uploading the quiz. Okay? Yeah, let me see who raised their hands. Somebody. Muhammad. KH Muhammad, I don't know what KH means. Muhammad Abbas, yes. Can you please go ahead, Muhammad?
Yes, Ankum, ma'am.
Yes.
Ma'am, I like to agree with Ali Samik because during this lecture as well, my internet dropped like 2 times. I had to leave the meeting because of that. So if you could increase the time window, that would be a huge favor.
Okay, yeah, I mean, I have the option of increasing the time window, and we have one more option that if you know, like, how to say it, like, if, for example, during that entire slot, your internet has been lost and you could not do the quiz, we may consider, I mean, we may think of considering your other quiz as double quiz. Just you need to give it, I mean, the next quiz will be considered as an extra quiz for you. And if you feel that at the end you ask me for one extra more quiz for your just a bonus quiz, let's call it, to overcome any of the previous quizzes that you have missed, that will also be an option. Okay? We don't want like other factors that is going just to affect your grade, that they are out of your hand. Yes, Ali. Ali, do you have a question? No. Okay.
Ma'am, I keep forgetting to lower my hand. I'm sorry for that.
It's okay. Anybody else want to say something? Okay, if you don't want to say here, you can email me and I'll read your email. Okay, and for a Friday session, who are attending today, you don't have to come again on the Friday session. It's just for the student who could not come today, so that in case they have any question, I can answer their questions. But I mean, it's not a must for you to come there as well. If you want to come, you're welcome. But if you are not want to come, that's also okay. So we are not going to penalize you for not coming. Okay, so please share your ideas, your suggestions, and if you have any issue. If you know that someone of your colleague is not able to have internet or anything, please let me know about that. Yes, Hamza.
Ma'am, I'm sorry, just one more question.
Yes.
Regarding the quiz that's going to happen next week,
Yeah.
are you going to be telling us the topics afterwards, or like abhi batayenge?
I will tell you, yes. So basically, they are going to be about those last 2 lectures of this feedback that we have covered. So most likely, I'll be asking you determine the polarity of this circuit. I mean, at each point, show me what's going to be is this node going up or going down, similar to those kind of examples that we did here. I might ask you to do a circuit and tell you find the loop gain of the circuit.
So Monday and Wednesday's lecture, basically.
Yes, and then we will have after that 2 more quizzes, and if we decide by a bonus quiz that's going to be optional for anyone who want to cover up a quiz that they didn't do well in it.
Okay. Yeah. Okay. Thank you, ma'am.
No, thank you. Anybody else is raising hand? Sheikh Abdullah, please go ahead.
Ma'am, I wanted to ask, would you be going over the Monday's lecture on Friday? A recap of it?
No.
Okay.
Because it really takes time from me. I cannot repeat. I had done a video and I did it on the live, and I cannot repeat it a 3rd time. So they are both available, like the Monday and the previous recording, and with the discussion. So they are both available for you on the YouTube and on LMS. So if you missed it, you can watch it, and you can come on Friday and ask me any question. Just write down your question before the session, so you may ask it at that time. Okay? Because I'm not going to say anything new unless I am answering a question. If I feel that I answered things that I didn't tell before, I will upload that for you, and I will tell you that this is important to see. But I don't think so. Okay, any other idea or question? Yeah, just if you know that somebody is not having internet by any of your friends, that they are in our class in both sections, please share this information with us. Okay, so I think we are done for today if you don't have anything else to ask or say. Okay. Okay, thank you so much. I'll share the recording of this one.